Alright, so today we're going to learn what is a composite figure and how to find the area of a composite figure using several different methods. So measuring is one of the common things that we do every day. Sometimes we have to measure floor plans or building plans or a couple of objects. And sometimes these objects aren't exactly in a specific shape that we know, such as a rectangle or a triangle. They might be many different shapes. And these shapes are called composite figures, but we're going to figure out how to calculate the area of these figures. So for example, here we have a house plan, and let's say that I want to change the tile or the floor in the bedroom to carpet or something else. We can see that the bedroom is an irregular polygon, so we're going to have to separate it into more common shapes that we know how to find the area of, for example, rectangles or triangles. And we're going to use the additive method to do this. So like I said, we're trying to find the area of the bedroom. So we're going to highlight it in blue to show what we're trying to find. And now we can clearly see that it's not a very common figure, it's in regular polygons. We're going to have to separate it into more common figures. Alright, so to calculate this area, we're going to have to divide this figure into more common figures such as rectangles and triangles. So our first step is going to be to find out what we're dealing with. So let's draw a ruler on one side and a ruler on the other side so we can count out what we got. Remember that each square represents 1 square foot. And we can see that maybe if we draw a line around the 9 mark, we could separate this into a rectangle. And if we draw another line, we can separate the bottom part into a rectangle and a triangle right here. Now we got 2 rectangles and a triangle, and we know how to figure out the area of rectangles and triangles. So we can definitely work this out now. So our first step is going to be to calculate the area of our top rectangle. Using the formula for area of a rectangle, which is length times width, we're going to have to find out the dimensions of the width of the rectangle first. We can see that it's got a width of 10 feet, and then the height, and that would be 9 feet. So now we multiply 10 times 9, and we end up with 90 square feet. Now we got to find the area of our bottom rectangle. So we can see that we got a width of 7 feet and a height of 5 feet. 5 times 7 is going to give us 35. So now to find out the area of our triangle, well, we repeat the same steps. We find out the dimensions of it. So we can see that it's got a width of 3 feet and a height of 5 feet. So remember that it's length and width divided by 2 or half. So 3 times 5 is going to give us 15. Half of that would be 7.5 square feet. So now that we have the area of all of our 3 figures, which is all of our shaded region, we can just simply add them, and this is called the additive method because to obtain the total area we add the areas of our individual figures. So 90 plus 35 and plus 7.5 is going to give us 132.5 square feet. The other method used for finding the area of composite figures is called subtraction method. What this method does is we find out the total area before we subtract anything, the unwanted part, and then we subtract the part that we don't need. So that part here is highlighted in dark blue, the triangle at the bottom right. So we're going to find out the dimensions of the entire area, which is going to be this rectangle in this case, which you can see that it's a 14 by 10, so we're going to multiply that. 14 by 10 gives us 140 square feet. Now all we have to do is subtract the area that we don't want, that we're not taking into consideration. We see that we have a triangle which is a 3 by 5. Using the area of a triangle formula, we work that out and we end up with 7.5 square feet. So now we simply have to subtract the unwanted region from our total area of a rectangle that we obtained earlier, and we end up with 132.5 square feet. And this is how we use the subtraction method. So we saw in the previous slide that you can use either the additive or the subtractive method to find out the area of composite figures. So to make sure you understand the concept of composite figures, take a few minutes and try to figure out the area of the shaded region in brown, which is the living room and the kitchen. You can use the additive method or the subtraction method, whichever you feel most comfortable with. If you're done calculating the area, then we can compare and check our answers now. Remember that even if you chose to separate the composite figures differently than what I am about to show you, the total area should still be the same. So we can start by finding out our dimensions. First, our easy ones. We see that we got a width of 3 feet and a height of 5 feet right here. We're going to separate that into a triangle. At the top, we got a width of 10 feet and a height of 29 feet. At the bottom left, we're going to have a height of 10 feet. Now we can start separating into common figures. We can separate the top into a rectangle very easily. That would be a 10 by 14 rectangle. Below that, we can have a 10 by 15 rectangle. To the side of that, we're going to have another small rectangle, a 10 by 3. And then above that, we're going to have a triangle, which is going to be a 5 by 3. Now we simply have to use the respective formulas, the formula for the area of a rectangle and the formula for the area of a triangle. Once we solve those, we simply add up all the values. So what we end up with is, we're going to add up our blue rectangle of area of 140, our green rectangle, which is an area of 150, our purple rectangle, an area of 30, and finally our triangle, which has an area of 7.5. And we add those up and we end up with 327.5 square feet. So to wrap up this lesson, maybe you can try practicing one more problem using the subtractive method to try to find the area of the shaded region here. Readiness. Determine solutions for problems involving the area of rectangles, parallelograms, trapezoids, and triangles.